Why are we here today? So we heard a lot of our prospects, customers, all the conversations in the past that they are still that everyone's tired of creating manually infrastructure as code. Now, infrastructure as code, it's all about automation. What has it to do with manual infrastructure as code? Of course, code needs to be written. And even in these times where AI is helping a lot, it needs to be verified. So there's still a lot of effort on validating the code that is created, creating the code itself. There's still a lot of ClickOps out there. And what we want to enable you is to generate infrastructure as code in minutes, as we say here, without having expertise on writing that code itself. Now, why does someone even need that? At first, what we see on a daily basis, manual codification doesn't really scale. Yeah, we see so many, in so many conversations, it says, yes, whenever we start something, we do it in ClickOps, but then at some point we need to have it in code because it needs to go through all of our deployment stages. But for quick testing, etc., it's still easy to click something together. Then there's still a lot of people out there that are simply using ClickOps to deploy their cloud infrastructure. Most often it's the knowledge gap of maybe the business users that now have to manage their own infrastructure, but they of course don't know how Terraform, OpenTofu, and all that stuff works. Or it was maybe also previously deployed with another code language, like people starting with AWS, maybe started with CloudFormation, now adding another cloud provider, and decided to go with Terraform. What do I do with all of that old stuff? And the last one is, of course, that there is maybe people that left the company, so the knowledge of that code that was produced left, and then it's very often also easier to recodify with the right tools in place than trying to figure out what the colleague did in that project before. Now, it solves for a lot of things, or there's a lot of other problems that are, of course, coming as a negative consequence to that. Everything that is in ClickOps is hard to manage. It's hard to control because if it's not in code, like written here, if it's not in code, it's extremely difficult or maybe impossible to control because you don't know what's out there, how it's configured, and what changes are made on that infrastructure itself. And that, of course, leads to outages. If someone Googles outages because of a drift or misconfiguration, that's you will get the full Google page most likely with the results that are not older than 2 weeks. And on the other hand, it's of course extremely difficult when you're in a regulated industry or you need to have evidence for an audit. And that, of course, leads then into, okay, I need to check all that stuff manually. And codifying resources is a quite heavy task if it's done in any other way. So usually the industry standard is 1 to 2 hours for a resource. And then imagine having 10,000 resources that are maybe out of the legacy from 5 years ago or 10 years ago when cloud was started in an organization. That's easily 2 to 5 years of work. And that's exactly the gap that we want to bridge with SGCode. Now, how does it work? It's a couple of simple steps. At first, what you will see today is we discover all your resources that are in your cloud account. So we scan the cloud account and detect all the resources that are in there. In that same step, you maybe want to give us read access to your state files, to your S3 buckets or storage accounts where you store your state files. So we can analyze what is really already in code and what is still deployed in any other way or in ClickOps. From there, we take those resources, we analyze the dependencies, so finding all the connected resources to that specific EC2 instance, for example, which usually has a VPC, a security group, maybe an IAM role, and so on and so forth. And then we convert that into Terraform or OpenTofu projects. And we don't just convert that into one big Terraform module. No, we modularize it and also do that according to your standards if you already have some. Now, the first part is then done. We now generated code, but of course we need to validate that. So that means we also generate a plan, and that plan should always show 0 diffs, so no changes no added resources, no deleted resources, so that you in the next step can push it into your Git repository, and of course monitor it for drift. And now there's one thing: when we already started in the first place to connect your state files, we will also immediately find out if specific state files already show up adrift, because we match it in that second exactly to what's configured in the cloud. So no manual import, no reverse engineering, and no guesswork to be done.